Hello and welcome to our CST 625 Computer Database Management final project. We are presenting our overall relational database design for a healthcare inventory management system, or HIMS. Our goal in this project is to design and normalize the schema and show how it supports key business functions like purchasing, stocking, issuing out to patients, and handling recalls and expirations. I'm going to pass it off to Harvey to tell you a little bit more about the team that you'll see throughout this presentation.
Thanks, Kentrell. So let's meet the team. The HIMS project was led by your very own Kentrell. Rashad took up the mantle of Team Scribe once we lost a team member here. And with support from myself, of course, Harvey Hargett, and Herman Hollins, we're thrilled to tell you more about this project. Let's go to Rashad to tell us more about the overall problem that our project is trying to solve.
Thanks, Harvey. In many hospitals, inventory lives half in spreadsheets and half in the EHR, or electronic health records. That causes shortages, waste from expiry, and big problems when there's a recall. Our objectives in phase one were to design a normalized schema that tracks items by location and lot, supports the full flow from purchase orders to issuing to patients, and adds recall and expiration management on top. Let's go to Herman to tell us a little bit more about the business functions that we found to be practical and can alleviate some of these pains.
Much appreciated, and thanks, Rashad. We defined 10 core business functions in the business function supported section. The first few are master's data, users, departments, locations, and items. Then we have procurement, purchase orders and lines, and clinical uses through prescriptions and issues, and stock transactions. We originally had an alerts function, but we refined that into a more concrete recall and expiration management function that matches the schema and queries we actually implemented. Finally, audit log covers who did what and when. Now we're going to go ahead and pass this back over to Contrell.
All right. So within this presentation, you're really just going to hear a lot of words about the actual specifics of our presentation. But what I wanted to get into was a little bit of the actual logic behind the actual project itself. As you can see, we actually have our ERD right here, to which we have added the total participation as well as the constraints and the cardinalities as well. And then I want to kind of just shift over here for just a second and actually show the logic behind this HIMS project. As you can see, what is being listed here is every single one of our demos. Our demos are not as simple as just a bunch of inserts. I have a bunch of things shown down here, and if you actually go inside of our code and scroll down to the bottom, each business function has at least two types of things that fit inside of that business function. Users and roles are the umbrella of it. However, within that, we have two different things that you can actually do here. And that is the case for each and every one of these. We have a few of these that will actually list certain different things within the hospital. I can expand this just a little bit more just so we can actually have a comprehensive view. But as you can see, this is going to list things where we have joined tables. We have a bunch of indexes on a bunch of different tables as well. But this is basically how you can organize a hospital's inventory management system, as well as having like staffing that's connected to these certain things within the hospital. Now let's continue the presentation. So let's get into it. Our ERD has 18 tables, groups into 4 clusters. Procurement handles vendors and POs, or purchase orders. Inventory control focuses on items, their subtypes as medications or supplies, and where they sit in the inventory at the lot level. Reorder point stores the minimum and target levels for each item at each location. Clinical entities represent patients, prescriptions, and all the other issues, and governance and quality. That really includes our staff, user roles, departments, recalls, and audits.
Well said, Kentrell. Here are a few of the types of entities as they appear on our conceptual schema section. Items hold the core attributes for anything we stock. Supply is the subtype for non-medication items such as your gloves and your syringes. Reorder point captures minimum and target levels for a specific item at a specific location. Inventory lot ties an item to a location with a lot number, expiration, and quantity on hand. Next up, you're going to hear from Herman.
Great job, Harvey. Thank you. Going into normalization approach, using the rubric, we repeated the same process for every table. For each table, we wrote the functional dependencies, found candidate keys, marked which attributes are prime and non-prime, classified FDs as very good or not, and then determined the highest normal form. If a table wasn't in Boyce Cog normal form, BCNF, we decomposed it into smaller tables. The result is that all tables in the final design are in BCNF. Now let me go ahead and pass this on over to Rashad.
Here's item in the exact style of the student's example from the instructions. First, we list the dependencies. Either item ID or SKU can determine the rest of the row. That gives us two candidate keys, so item ID and SKU are prime and everything else is non-prime. Because both functional dependencies have a candidate key on the left, they are very good FDs. That puts the table in BCNF, so it doesn't need decomposition.
To continue from Rashad, normalization example of a purchase order line and a reorder point. A purchase order line and a reorder point are good examples of relationship tables with composite keys. For a purchase order line, the combination of a purchase ID and a line number uniquely identifies a line and determines the rest of the attributes. For a reorder point, the combination of an item ID and a location ID determines the thresholds. In both cases, the only non-trivial FD is from the full key to the non-key attributes. So both tables are in BCNF and do not require decomposition. Earlier in design, we did decompose a wider item concept into item, medication, and supply, and a wide inventory concept into inventory lot, inventory transaction, and issue. Those decompositions are already baked into the final schema. Let me go ahead and give this over to Harvey so he can continue for you guys.
Well said, Herman. Instead of modeling an abstract alerts table, we decided to implement a more concrete recall and expiration management function. Recall reference items and a recall level. Inventory lot tells us which lots and how much we have at each location. Issue and prescription let us trace which patients have received those lots. We also use expiration date to get expiring soon and expired stock lists. Now you're going to hear from Rashad.
We implemented a full set of demo queries that directly tested our business functions. For example, we can list items that need reorder, identify lots that are expiring, show PO lines that are partially received, and trace recall impact from stock to patients. To support these queries, we built a seed script with at least 40 rows per table and tested the queries until they returned meaningful results rather than empty sets.
All right. To wrap up, our HIMS design supports purchasing, inventory, clinical usage, and quality functions like recalls and auditing. Every table was normalized to BCNF using the rubrics process. We also built realistic seed data and demo sequels to prove that the design works. Going forward, we could add forecasting, vendor integrations to where if they have the actual permissions, they can actually have their own little portal that goes with this bigger database and a mobile or barcode interface. We divided the work across requirements in schema, normalization, and implementation and testing.